Hello students, I hope you're enjoying your first week back at school. I'm going to talk to you today about inequalities. The TEK for this lesson is TEK 1A.5b. It's coming from Algebra 1. Solve linear inequalities in one variable, including those for which the application of the distributive property is necessary and includes variables on both sides. So, we're going to work on this today. Let's get started. So first of all, we need to understand what an inequality is. An inequality is anything that has a less than, greater than, less than or equal to, or greater than or equal to sign. So here they are listed right here, right out beside what each one is. This first one right here is a less than. The one underneath it is considered a greater than. Notice that the greater than, it opens on the left side. That's because when you're reading left to right, remember the alligator opens to the bigger portion. So if you're reading from left to right, if you have something over here, you want to say this is greater than what's on the other side because it's opening up towards the left-hand side. So the left side is greater than the right side. Over here, we have the less than or equal to. If there is a line underneath it, then that means it is equal to also. So less than or equal to. And then the next one would obviously be greater than or equal to. Okay. So let's go ahead and go on. You are going to be graphing these today, and so when you're graphing, let's look at the less than or greater than sign. Less than or greater than, when you graph it, it has an open circle. And you can remember this because it's open because it could be less than or greater than, but it cannot be equal to whatever number you're putting that circle on. The less than or equal to, greater than or equal to is going to be what we call a closed circle because we want to include the number that you put the circle on. So we're going to close it up. We're going to fill it in so that we can say that that number is included. All right, so let's go ahead and work the first problem. Okay, when you solve an inequality, we want to get the variable on the left-hand side, just like you would on an equation. So the very first thing that I'm going to do is I'm always going to move my x's or my variables before I move anything else. Now if I want to get everything on the left-hand side, or at least the variables on the left-hand side, you'll notice that you're going to want to subtract the 6x to the other side. Now a lot of people at this point, they say, well, why can't I move the 2x to the other side? Because I want to deal with positive numbers. Well, you can, it's just that at the very end, you're going to have to move the x back over to the other side anyway, so you might as well as just start at the beginning, moving it to the left side. So we're going to cancel this out, and so now we have 8, 2x minus 6x is negative 4x, and then we have less than or equal to the negative 20, because the negative is going to come down with it. We subtract 8 to the other side, and so we have negative 4x is less than or equal to negative 28. Okay, at this point we're going to divide by the negative 4. Now, very important, anytime you multiply or divide by a negative, only then will you switch this sign. So right now it's a less than or equal to, but because I had to divide by this negative 4, I need to now switch this and make it go the other way. So it's not going to be a less than or equal to, now it's going to be a greater than or equal to. Now negative 4 divided by negative 4 cancels, so I only have that x left on the left side. And then on the right side I have negative 28 divided by negative 4, well that gives you 7. So I have x is greater than or equal to 7. Okay, so over here we're going to draw a number line because I want you to graph this. Graph what this means. X is greater than or equal to 7. So on my number line, I want to make sure that I have the number 7. And then I want you to have two numbers on either side of it. Okay, so On the left side, it would be going down, so 6, 5. I also want you to include where the 0 is. So over here somewhere would be my 0. And then on the other side of 7, I have 8 and I have 9. Okay, x is greater than or equal to 7. So at 7, because it's greater than or equal to, that means that I'm going to color in this circle because it can be equal to 7. But it has to be greater than or equal to, which means I'm going to shade in the greater than direction, which would be to the right. Okay, now you have it graphed and solved, so you are done with this particular problem. Okay, let's move on to number 2. So we're going to solve this just like a normal equation. The only thing different is that if you divide or multiply by negative, you have to flip the sign. Okay, so we're going to go ahead and distribute this negative. Negative x minus 6 minus 2x greater than or equal to 12. Get used to saying what that sign is because I'm going to ask you in class to name what the sign is when you're describing this to somebody. So negative x minus 2x, that's negative 3x. And then minus 6, all I'm doing is collecting my terms right now. And now I'm going to get x by itself, so I'm going to add 6 to the other side. So I have negative 3x greater than or equal to 18. Okay, but now I'm going to divide by the negative 3. Right away, when you divide by that negative 3, I want you to switch the inequality. So now the negative 3's cancel, and I have x, because I have to switch that, it's now going to be less than or equal to. 18 divided by negative 3 would be negative 6. So when I draw my number line, I'm going to have negative 6 on there, but I want some numbers on the other side of it. Okay, now keep in mind, if I'm going down from negative 6, then my numbers are actually getting bigger. So I've got negative 7, I've got negative 8. Okay, when I go above negative 6, it's negative 5, negative 4. It's getting closer to 0. Now where's my 0? My 0 is going to be over here somewhere. So I need you to put that on there. At negative 6, we're going to have a closed circle because it can be equal to negative 6, but it has to be less than or equal to negative 6, so that would be on the left side. Less than, left. And I just go ahead and shade that in. Okay, moving on to number 3. Why don't you go ahead and try that on your own, and then when you're ready to check your answer, unpause the video and check your answer. Okay guys, I hope this didn't stump you, because you were probably working it and thinking, hey, I think I made a mistake because this is not supposed to happen. Well, okay, let's check our work. So I went ahead and distributed the 3, so I have 3x plus 6. That's less than 3x, okay? Well, then when I subtract the 3x, then I end up with 0 on the right side, and I have 6 on the left side. So that 6 is less than 0. Okay, well, is 6 less than 0? And hopefully your answer is no, because 6 is not less than 0, okay? This is not a true statement. So we say that this is a false statement. 6 is not less than 0. If this is a false statement, then this one is actually no solution because it's false. Okay, false equals no solution. But you have to get to this point to determine whether or not it's a false statement. Okay, well, let's look at the next one. Let's work through this one together. So we're going to take the 4 and we're going to distribute it. Now, 4 times a negative 1/2. Well, what's half of 4? It's 2, and because we have a positive times a negative, then it's negative 2x, and then 4 times 1 is 4, so we have plus 4. That's greater than negative 2x. Okay, let's get the x's on one side. So we're going to add the 2x to the other side, and you're going to start to see what's going to happen. Okay, so I'm moving this over. That means I have 4 is greater than 0. Okay, is that a true statement? Yes, it is. That is a true statement. 4 is bigger than 0. It's greater than 0. If this is the case, your answer can be any number whatsoever. I can take any number and plug it into that x and make that a true statement. So what this is going to be, what the answer is going to be is all real numbers, meaning I can plug in any real number to this inequality and it is correct. All right, so I want you to keep in mind, if you get the x's to cancel out, or any variable for that matter, you get it to cancel out and you get a true statement, then it's all real numbers. If you get a false statement, that means that there's not a number that will work in there. And so for that case, we just say no solution. Okay, I hope this has been helpful. Please answer the WIS document at the end and come to class ready to discuss. Thank you.